Welcome to my presentation. Seaside is different by design. We share as much state as possible. We don't use meaningful or RESTful URLs. We don't have a templating system, and we don't think we need one. Seaside is written in Smalltalk. Smalltalk, as it was already mentioned several times in the previous talk, is a very nice object-oriented language, and we got things basically right already 20 years ago. So talking about age, I might introduce myself quickly. So my name is Lucas Franklin. I have sort of three personalities. So one of them is the academic side. I'm a PhD student at the University of Bern in Switzerland. Then I'm working as a software engineer at NetStyle. This is a small internet company in Bern where we basically develop web applications using Seaside. And then I'm a core developer of Seaside. I develop mostly at night and in my free time. And I'm also an author of two quite important frameworks to Smalltalk. One of them is Magritte, which is a meta description framework. And of course it also has some bindings to Seaside. And Peer is a content management system, obviously built on top of Seaside. All right. So what is the agenda for today? I'm going to do quite some coding and quite some examples just that you get a feel for how it is to develop a web application in Seaside. So I will start my presentation with a short motivating example. I will show you how you develop web applications in other frameworks and how we solve this particular problem in Seaside. Then I'm going to talk about the missing templating system in Seaside and what kind of solution we have for that. Then I'm going to talk about callbacks, components, and finally the big buzzword of the last and maybe also this year, Web 2.0. And to end my presentation with, I would like to show you some productive applications that have been written using Seaside and use that sort of to wrap up my presentation. All right, so let's start out with a simple example. So imagine a web application, a very simple and stupid web application where we sum up two numbers. So the requirement here would be that you ask the user for a first number, he clicks OK, and on the next page you ask the user for the second number, he clicks OK, and on the third page what you do now is just to think a few seconds how you would solve this problem in your preferred web application framework. I'm sure it's a very simple and stupid example. Everybody could come up within a couple of minutes with a solution that would work. Just to tell you, in fact, quite a lot of web applications have sort of that, such a system somewhere in an application. For example, I once developed insurance applications where people could choose different insurance policies, and this is sort of like giving a number, and then in the end they sort of got a summary where they were presented with the total cost for these insurance policies. So in fact this is just a simplified example of that. So how would you do that in your preferred web application language? So I'm pretty sure that you would probably split that up in 3 files. Maybe you would put everything into the same file. That doesn't matter much. Basically, you have 3 parts. So first HTML, second HTML, and result HTML. And the bad thing about this is that you have references to other files and other parts all over. So in the first form, you have sort of a reference to the second file, and in the second file, you have a reference to the result. And moreover, then you have references between the variables. So the input field, I call it value 1, somehow has to be passed to the results to calculate the sum of those both numbers. So it has to be passed to the last page. And now, of course, everybody should shout, yeah, that's not possible in HTML. Unfortunately, that's not possible. So I have to sort of introduce here a hidden field that takes my value 1 and then passes it to the last field. And the same for the value 2, of course. So I need to somehow pass my state all along this session. And now imagine if you would add another step in the beginning, like to ask the user if he wants to multiply or add a thing. Then you would basically need to modify all 3 existing files to accommodate such a simple task. So let's step a little bit back. So how basically all web application frameworks work. There is a web browser somewhere in the world, and he sends out a request to the web server. And what the web server always does, basically, when a request comes in, he starts up a request processor. He parses the URL, he processes this request, he starts some formatting routines, and finally sends back the results to the web browser. So in our case, this would be the form asking for the first number. And then the web browser sends yet another request out, and the web server would again parse the URL, parse the value, maybe convert it to a number, process all that state, and generate yet another HTML output file that also includes value 1, yet converted to a string again. And this goes on and on. So the next request would include value 1 and value 2, and your web server would again need to parse that stuff, to process that stuff, and well, in here there would it actually add those 2 numbers, but it requires a lot of code just to add 2 numbers. And what I want to ask you now is, who really cares about HTTP anyway? If you want to develop a web application, you don't care about HTTP, about this low-level HTTP protocol that has been invented years ago. Anyway, what you want to do is to have a good abstraction that allows you to compose web applications easily, like you do for a desktop application. And this is basically what Seaside is all about. So Seaside is different. Basically, in this gray box, there is everything you need to run this simple example that I showed you on my first slides. And now this involves a little bit of Smalltalk programming, but I will explain every step, so there is no need to be afraid of. So the first thing we do is we declare 2 temporary variables. So value 1 and value 2. Could also call them A and B, whatever. Then the next line, what does it do? So it basically displays this input field and puts a title on top that is called first number. So what this method call basically does, it sends self-request with an argument first number, and then it assigns the result of this function call to the variable value 1. And obviously, the second line, I'm sure you could guess how this will look like. So it will call the same function, the function request, with a different argument, a second number, and assign the result to the variable value 2. And last but not least, we have a method called inform that will just display a string on the web page and will convert those two values to numbers and add them up and show them as a result. So that's really all you need in Seaside to solve this problem. All right, so this will bring me to the first demonstration. What we see here, so that's the wrong window. So what we see here is this application. So this is a small doc code browser. You don't need to worry too much about that. What you basically have here is, here are the classes. These are all my examples I'm going to show you during this presentation. And on the very right side, you have a list of the methods. And in this case, this is just one method with the code I showed to you on the previous slide. And if you open this example in the web browser, it does exactly what you do. So if I add the numbers, I get the result. And amazingly, I can even use the back button. So when I go back and maybe change the number here, what Seaside will do is basically to backtrack in the code and re-execute the already existing code, and as you see here, return a second time from this function call, but with a different return value. And that's why in the announcement the name continuation was mentioned. I'm not going to talk about continuations here because that's just an implementation detail, but that's basically what enables this technique to have a flow of pages defined in a clean way, in a single method like this. All right. So let's talk a little bit about the missing templating engine and why we don't need a templating engine. So the basic idea of Seaside is that XHTML is produced by the developer with the help of Seaside. So what we have created is a small little DSL that helps the developer to create valid XHTML. And now you wonder, yeah, how do we get the design? But that's what CSS is for. So CSS is done by the designer, so we have a clear separation of the markup and the design. Of course, the designer and the programmer sometimes need to talk a bit to make sure that they use the same class names and IDs, but fortunately this works quite well, since also the support of CSS is now quite good in all common web browsers. So how does this DSL look like? It basically follows the principle of canvas and brushes. So you have a canvas where you sort of paint on with brushes. So on top you see some small doc code, and below the resulting XHTML code. So what we have is sort of a variable that represents the canvas and is called HTML. And we ask this canvas for a div tag, and we configure this canvas to have an ID called list, and then we give it sort of a block that's exactly the same as the blocks in JRuby or in Ruby. And inside this block we can specify basically the contents of this div tag. And as you see, there is nowhere any code that closes the div tag. This is ensured by Seaside. At the end of the block it will automatically close everything and make sure that this is valid XHTML. And the same happens basically inside this block. So we ask the canvas for a span brush, we give it a class name, and we render a string inside so that item 1 and item 2 will appear in those two span elements. Alright, so let's do yet another small demo. What I have prepared here is a small application that overrides this method called render content on. This is basically a hook method that is automatically called by Seaside to let developers output XHTML. And when we have a look at this application in the web browser, it will obviously just generate this string. And what we can do now is oh God. What we can do now is to maybe display the current time here. So I say I want to create a div tag with the class now, and as the content I want to display the current date, for example. So I compile this code and it's immediately activated in the system. The only thing I need to do is to refresh here, and then I see the current date inside on this web page. So you maybe have noticed the toolbar down here. And this is basically only displayed in development mode. When you deploy your application, you disable this toolbar. And this toolbar provides a lot of quite cool tools to ease and improve the speed of development. So for example, there is XHTML validation. You can profile your application. You can have a look at the memory consumption of your application, etc. And probably the most or the coolest thing is the hellos that you can enable, and that will sort of start a different rendering mode that shows the structure of your website. So in our case, we are just using one single class. This is this example 3 class. And it provides some tool here on top. During the following demos, I'm going to show you some more features that are available here. But what I'm going to show you just now is the code browser here inside this web interface. So what this opens is basically a code browser within the web application. And of course, this is also written in Seaside. And you see it's basically the same view as we have in our development environment over here. So the current class is already selected. I can just edit the code here. So for example, I can change it time now, and then instead of the date, it will display the time instead of the date. So when I accept the code, you see it immediately changes here in the development environment as well. I just need to close here this system browser, and without restarting or recompiling anything, it just displays the new functionality inside the running session. All right. So the next part I'm going to talk about are callbacks. So the principle here is that we don't want to have to do anything with request parsing or with response generation. We want to let the framework do that for us. So the basic idea of callbacks is that you don't ask for any values in the request, but you let Seaside call you and provide those values to you. And it's probably the easiest way to explain this that I just show it to you with my third demonstration application. So this displays just an input box, and I can type something like my name and say hello, and then it will display an info box that concatenates the string sort of. And how is this implemented in Seaside? So as you imagine, this is quite simple. Again, we override the render content on method, this hook method that is automatically called by Seaside. We ask the canvas for a form tag. We ask the canvas for a text input tag, and then we provide a callback that gets a block as an argument. So as you remember from the Ruby talk, a block is just an anonymous function or a closure or a lambda expression, whatever you want to call it. And this block gets basically the value that comes with this input field as an argument and assigns it to an instance variable that is called username. And then in the submit button, that works very similar. Here we have a callback that just displays this username concatenated with the string hello. If we go back to our application and toggle on the hellos, there is another nice functionality that is called source view. So you can have a look at the source code of the running application, and here you see that actually many more tags have been generated for you without actually that you had to specify those. Like the form tag had some additional attributes added automatically. The input tag had a name specified, and this is basically how Seaside later on then knows what callback it has to evaluate to pass in this text into the callback block. The same is true for the submit button, and then some more hidden fields has been automatically added by Seaside so that it can identify the user session. All right. The next big thing about Seaside are components. Seaside programmers don't think in pages, but in components. Every component in Seaside has its own state that persists over the whole lifetime of a session. And those components can be also thought like widgets that you have in a desktop application. So you can compose components into each other, you can nest them, you can display them, you can hide them, you can decorate them, etc. There are all kinds of nice properties that components have. And there are also obviously libraries available that provide ready-made components for you to use. These are sort of widget libraries for your web applications. And of course, the main advantage of having such a component system is that you have increased reusability, because you can basically reuse those components in different places of your application, or you can even share them among different applications. So this is a simple demonstration of such a web application user interface that has been built using many components. I think you can already guess what components are involved here. So we have a register widget here. There are even two instances of register widgets that are nested into each other. Then we have sort of a filter component into one of the register sheets, and some statistical components that display this pie chart and a table with the data. All right, so let's go back in demo mode. Let's first have a look at the source code. So this is example 5. We have here, in this class, we have an initialization method. This is automatically called by Smalltalk when this class is instantiated. And what it basically does, it just creates an array with instances of components that you have already seen in the previous examples. So it will create 3 instances of this summing up application. It will create 1 instance of example 3 and 2 instances of example 4 and put them all in an array. And then if you have a look at the rendering method, which will display those elements, it simply iterates over those components, separates each of them with a break, and obviously displays each of them. So if you have a look at the application, then it obviously looks like this. So we have 4 times our summing application, and we can use each of those sum up applications independently without actually providing any more manual, without actually doing anything special. So every of those is working completely independently. It has its own flow defined. And of course, if we now enable the hellos, you see that the composition of this web page is not that simple anymore. There isn't just one single component visible at this time, but there is example 5 that is around everything, and in here you basically have those other example classes that are used to display or to render this part of the particular page. So another neat thing about Seaside is that you can do a lot in the debugger. So let's just introduce a tiny little error somewhere here in this code. So just to make it simple, I introduce a division by 0, so I compile this code. And if I go back to my web application, it will obviously throw an exception, and this probably looks similar as it would in PHP or some other language. It would just display a stack trace, but there is one big difference, and I'm sure you already noticed. There is a link on top here that says debug. So if I click this link, I basically get a debugger here in my programming environment, already selecting the part of the code that caused this exception to occur. So let's fix this error by just removing this division. And then I can just say proceed, which will just proceed within the current session. And if I go back here to my web application, you see, I didn't lose any state. I didn't need to restart anything. I'm just exactly at the same position that I was before. And this is a big time saver if you are hunting bugs in your application. All right. So this brings me to the Web 2.0 part. So Seaside already provides a big integration to Web 2.0 technologies. Unfortunately, it's not very clear what Web 2.0 actually means. So if you have a look at Wikipedia Web 2.0, then you see a huge list of things that is considered to be Web 2.0. So one of them is valid XHTML semantically valid markup. And obviously Seaside has that because its DSL basically enforces the developer to create valid markup. So that is done. Then CSS, cascading style sheets. I assume that your designers are using a style sheet validator, so that shouldn't be a problem as well. So that's done. RSS is also considered to be part of Web 2.0. There are some libraries in Seaside that enable you to create RSS feeds in very similar ways as you do with XHTML, so we can agree with that as well. And the interesting thing, at least I think, is AJAX. So AJAX is really something that can be used for many things, and as it said, basically multi-usage. So those who has used AJAX, who knows what AJAX is? Oh, yeah, all of them, right? Well, so let me just explain in a few sentences. So what you do with AJAX basically is to emit a request in the background and to ask your server for some updates, and then inside the client, inside the web browser, you use JavaScript to update only a part of your page. And then obviously everything seems to be much snappier because there is no reload and redraw of the whole page. Alright, so Seaside has several integrations of AJAX libraries. What I'm going to talk to you about is the integration of the prototype library and the Scriptaculous library. So these are basically two libraries that integrate very well with Seaside and that are also very well known in the Ruby community, I think. The integration of JavaScript into Smalltalk is tight but optional, so you can write Seaside applications that don't have any JavaScript in them. But if you want, you can have full support for basically anything you can do with JavaScript. The integration of Scriptaculous is feature complete and up to date, so basically, or usually a few hours after a new release of Scriptaculous, you can get the new integration for Seaside. And we do it similar as the Ruby guys, so we want to say everything in Smalltalk. We don't want to use another programming language, so we don't really care about JavaScript. In fact, it's just that, unfortunately, web browsers don't understand Smalltalk. So what we do, actually, is we transform Smalltalk code to JavaScript. So in this example, we ask our HTML canvas for an effect object, and then we tell this effect object, for example, to shake. And this will result in the JavaScript code, new effect, shake this. And I'm sure I can show that to you in a moment. So I've built a tiny little AJAX application. It just shows the number, and whenever I click it, it increases this number by 1 without actually reloading the whole page. As you notice, when I do a non-AJAX call, like clicking on new session, it will take a little bit longer and will show a progress bar on top here. Of course, since everything is running on my local machine, it's quite fast still. So what we want to do is to modify this code to let the number shake whenever it's pressed. And so let's have a look at the source code. So this is example 6, and this is basically all you need to implement this functionality. I'm just quickly explaining how it works. So we ask the canvas for an anchor brush, and we assign an on-click event. We ask the canvas for an updater object, which will allow us to update part of the page. In this case, we just want to update the anchor. Again, we define a callback, and that callback will pass in a new canvas where we can paint on to replace the current content of the anchor. So in our case, we just increase the number by 1 and display the new number. So now what we can do to make it also shake, not only to update, we just concatenate this JavaScript code with HTML effect shake. And that's basically all. So if I go back to my web browser and refresh the page, then it will also shake when I update it. And when we have a look at the source code, you actually see that there is quite a lot of JavaScript code generated for this actually quite simple functionality, and you don't have to care about JavaScript that much when you are using Seaside with this tight integration of Scriptaculous. So another interesting, or another buzzword in the last year was Comet. So who has heard about Comet? Not that many people. Actually, it's just a buzzword to the server push technology, or also known under the name HTTP streaming. So one of the problems of web applications is that the web browser, if he wants to get an update, he always has to ask the server for an update. It's impossible basically for the server to push changes to the client. And Comet is sort of a JavaScript hack that allows you to push changes from the server to the client. And I don't want to talk about that too much. Just show you the demonstration. So we have, again, a tiny little example application where we can increase and decrease a number. And since this is using Comet, since this is running using Comet, I can just open multiple browser windows. Yeah. So we have to make sure that everybody can see them. Of course, it doesn't need to be, not all the browsers need to be the same web browser. I can also use Firefox, of course. So let me also open one in Firefox. And basically when I click here in any browser window, instantaneously it updates all the websites that are on the same URL or on the same web page. And this is quite cool because it's very easy to do that in Seaside. It took me basically only an afternoon or an evening to implement that. And I know that a lot of web frameworks are struggling with that because their underlying programming language and their underlying web server is simply incapable of providing such a functionality as HTTP streaming. Of course, this counter example isn't really exciting. We also have a little chat client, so I can say this is Safari. Then let's open the chat client here on Firefox as well. So I can, when I open those windows next to each other, I have to make this a bit smaller. Or maybe type it from here. So I can actually use this as a chat client. And there is no delay in the updates from Safari to Firefox, nor from Firefox to Safari. So this is Comet. Of course, you can do that without writing any JavaScript code because that has been already done for you. All right. So now you wonder, certainly if Seaside has been used in production. And I must say, yes, it has been. Quite a lot. It's in productive use since 2002. I have been involved in many productive applications, and all over the world people are deploying applications using Seaside. And these are just a few screenshots that I found on the web. Some of them I have been involved with, so this one here, this is my website running Peer. Well, maybe you know some of those, maybe you don't. These are all basically highly dynamic web applications, and this is where Seaside is strong at. Now I want to show you two web applications a little bit more in detail. So this is a web application that the company I'm working for has been released just a week ago, and it's quite a neat AJAX application. It's sort of a competition in Switzerland where schools can subscribe and create a website, and they subscribe on this website and they basically choose a place on this island. And this actually works very much like Google Maps. So they choose a location on this island where they virtually place their website. And then later on, right now that there are no schools registered yet, but later on people will be able to see all those websites on this island and have a look at them and vote for them, and finally the class with the best website will win something. And this is another application that I'm proud to present to you. It has been just entered the beta phase, and it's a quite novel kind of a content management system called CMS Box. So let's have a look at this application in the web browser. I have to make the fonts a little bit smaller. Alright, so this is the CMS box as it looks when you come to it as a visitor. So basically pages with text inside and some broken images, unfortunately, because I didn't copy all the data from the server. Anyway, that's not too much interesting for you, right? What is interesting, how you edit and how you provide the content. And I think this approach is quite cool and novel, so I will log in as editor. And not much changed yet, but we have now a button that is called Edit on top here. And when I click Edit, I sort of enter the edit mode, but from the website, nothing really changed yet. There is just a toolbar that appeared on top with gorgeous little icons. And there is some functionality down here, so I can actually select any part of the user interface. I can drag content around to a different column. I can edit things in place, so I can type something and everything will just happen without that you that you use a different user interface. Most content management systems requires editor to use a complicated user interface that looks completely different than what they are, what the final result looks like. Of course, we have multi-level undo, so I can undo any change. So this will undo the edit operation, etc. I can of course also redo changes. There are other operations as you would expect, so I can cut things and pass them somewhere else, etc. There are of course also properties, so I can change the layout as the designer specified in the style sheets for the website. And yet another neat feature is the history. So in the history I can basically go back in time. It's sort of like the time machine. So I can sort of go back to any date in the past, like, well, the 1st March. And at that time the website looked completely different. And now if I accidentally deleted something, or if I want to republish something that I already had a long time ago, I can just go in here and, for example, say, yeah, I want to copy this image. I go back into the edit mode and I can just paste this content in here as I have it in the clipboard, right? So this is the CMS box. So, did you notice during my presentation we were talking about web applications and not about desktop applications, even so it maybe felt a little bit like desktop application development. I didn't specify a URL anywhere, so Seaside takes care about all the low-level stuff, about the URLs, the naming of input fields, the naming of anchors. Everything is basically done for you. You don't need to touch anything of the HTTP protocol. Of course, some developers might want to have some control over URLs and provide RESTful and provide state in their applications. It is possible if you want to. As you can see, for example, on my website, where I have bookmarkable URLs. But by default, Seaside doesn't doesn't require you to know about anything that is in any way related to URLs. There is also no request parsing, basically due to the fact that arguments are passed into callbacks and then are just evaluated, and you get the values. You are called. You don't have to ask for values. Then a great thing about Seaside is that you are very efficient. This is basically due to the nice tools that you have in Smalltalk, like the debugger that tightly integrates with Seaside, so you can change code on the fly of your web applications. You don't have to restart or recompile anything. And as we saw in the first example, you can define workflows at ease by just implementing a method that can contain loops or if statements, and where the result is just returned from a function call. And this makes it very intuitive and easy to define a complex workflow. So I would say this is more like Web 3.0, no? If you have any questions, please feel free to ask. Yeah. And this is basically the place with the workflow where you are actually required to have continuations if you want to support the back button as well. So several people have tried to implement a Seaside in Java. And since Java doesn't have continuations, they tried to sort of simulate them using threads that they suspend at a certain time and resume when the next request comes in. But since threads cannot be copied and threads cannot be backtracked or put into a state that had been available before, the back button suddenly stops to work. And if you have ever developed a web application, you know that people like to use the back button a lot more than any web developer would like, because the back button really complicates things. And continuations are basically the key to support the back button. Yes?
Saved as a Smalltalk image, is it right? So what about kind of serializing and database integration and other stuff?
All right. So Smalltalk provides an image, as you mentioned. This is basically a space in the memory where all your objects live. And during a session, of course, the state is just kept inside this image as objects. And there are different ways to serialize this state. So there are XML exporters or relational database bindings, or object databases are very nice to use in Smalltalk. Seaside is a web framework. It doesn't enforce you to use any of those persistency mechanisms. So you are basically free to choose anything that is available to you, any library or any binding for a persistency mechanism. Yes?
For example, pure XML instead of HTML?
Yeah, certainly, yes.
So you can combine it with other technologies?
Yeah, like I said, so there is an integration for RSS. So that's just a different XML format, and I'm sure it would be easy to provide other XML output formats. Hosting. Yeah, that's an interesting question. And also allows me to give a little bit of advertisement. So at NetStyle we have implemented, together with the support of AJAX, which is the European Smalltalk user group, a free Seaside hosting service where you are basically able to upload your Smalltalk code and run your Seaside applications for free as long as they are not commercially used. So we have currently more than 300 people that have registered there, and there are about 100 Smalltalk Seaside applications running on our server. Now, if you want to do commercial development, you probably need to subscribe to a hosting service that provides you a Linux box, a virtual Linux box where you can install your Smalltalk system and run Seaside on there. That's usually not really a problem. Does that answer your question?
All right, so I read, before this lecture, I read some things on the Seaside webpage, and I read that it is a kind of application server. So is it possible to adapt it to another protocol, to use these cool things in another kind of protocol, no HTTP, but some kind of, I don't know.
What do you think? Yeah.
Like remote method invocations or something like that. Not as a presentation layer, but as an intermediate layer or...
Interesting idea, yeah. I sort of thought about that once when implementing an FTP server, but I couldn't really come up with a useful use case. But maybe the thing with remote method invocation would be interesting to evaluate. Yeah. It would be certainly possible to use Seaside or just the same approach to do something like that.
Bind it to HTTP or just have some kind of...
Yeah, it has a lot of hook methods, Seaside, so you can basically subclass or extend existing classes with new methods.
So it is possible to implement another kind of protocol in request-response manner. Yes? Yeah,
I would say so. So the RSS integration is basically just doing that. It is modifying some parts of Seaside to enable it to generate RSS feeds. Yes.
Does the Seaside framework support web services?
Not the Seaside framework itself, but there are libraries that allow you to do that, yes.
So it's done on a low layer, yeah?
Yeah.
And the second question, the thing that always bugs me when I write websites that are images that are generated on the real time. For example, I'm rendering a map, and I want to draw something and then display it in a web page, and I want to do it in one code. Don't separate the image generation code from the code that invokes it in a web page. Does the Seaside framework have something to help me to do it?
Yeah, sure. It's everything object-oriented. It sort of follows the model view controller pattern. And as you saw in this screenshot before, I'm not sure where this is. It's over here. So this is basically what we're doing here. These pie charts are dynamically created on request, right? So there is a special class that knows about how to create this image, and then this image is served by Seaside. So this is sort of separated code. Then you have another view onto the same data. So this table is then basically created by a HTML view, XHTML view. Yes. Feel free to ask any questions. I actually hoped that somebody would ask a question about continuations, but never mind.
One of common problems with developing pages is when you move snippets of HTML code or code which generates HTML actually to another page, it can blow up the page because it's connected with CSS of other kind of presentation. So does Seaside provide some mechanism to move dynamically a CSS from one side to another to just paste and move not only the code but also attributes of it?
No, not really. So in this case, I suggest that you have to fix your CSS. So more work for the designer then. All right. Thanks for listening. Or performance. Yeah, as you see, Seaside on my machine, on my local machine, it's very fast. And you can scale it extremely well by just load balancing one, by throwing new machines at Seaside. So one of the drawbacks of Seaside is that it is quite memory hungry, since it keeps basically all the stack in memory. So what we count is about 2 megabytes per user session. And so you can do the calculation for yourself how many sessions you can host on a server efficiently before needing to add another server. But usually this is just a trade-off between development speed and ease of development against hardware. And hardware is usually cheap, and development time is usually expensive. So I think it's a good thing.
So if you are talking about scaling, what about sharing the state of the application between servers? Because there are basically two types of scaling application. One is stateless and one is stateful. When a single host manages a state, you must redirect all the requests by some kind of load balancer which is aware of the session. So is it possible to use a stateless strategy, or you must use a stateful because all the states
you must use a stateful strategy? Because when one server has the data about the session, then all the following requests have to go to the same session. But what we usually do, we just have Apache that sort of at random points the session, a new session, to one of our servers, and then always keeps the same connection open. Any more questions?
Yeah. How about security? Say it seems like you have all of these sessions going on in the same image. What if some user managed to crash one session, his own session? Wouldn't that affect all the sessions running in the same image?
Yes. If it really crashes, but that rarely happens. But potentially, if you manage to crash from one session your whole machine, then of course the other sessions go down as well.
Actually, I was interested about the CSS stuff because getting real-world commercial web designers to do everything in CSS is kind of hard. They don't like that, and the reason is basically, and that's a follow-up question. The HTML, the XHTML that Seaside generates, how does that work with all the browsers? Does Seaside generate code that can be passed and used by all browsers, or is there requirements on newer versions?
Yeah, basically you can choose the XHTML standard yourself. You can also generate, if you really want to, you can also generate invalid HTML. But usually, or the default setting, I think in the latest release, is that it will generate XHTML strict 1.0 or something.
So what about design? I mean, most designers like to use tables, HTML tables.
Yeah.
Is there a way of turning, say for example that you get an HTML file, is there a way of turning that into the equivalent Seaside generation code?
Yeah, I mean, you can use tables in Seaside as well.
Yeah,
I mean, there is.
But you have to
tables
manually transform it from the HTML that you get from the designer into the Smalltalk code.
Well, usually we do it the other way around. So the developer creates the XHTML very basically, just by having a logical markup structure, and then he passes this XHTML to the designer that does the design afterwards. And maybe there are some iterations between those two guys, and finally there is a result. This is what we did for the CMS box, for example.
But the problem is that most designers want to generate, they want to create HTML, and they want your application to emit it, because they don't like doing design with CSS.
Yeah, that's just a different mindset. I mean, you have to find the right designers, and there are obviously designers that do that. All right. Thanks for listening.
Thank you very, very much.